Okay. Good morning, one and all. In last lecture, we have started the unit number third, and the only last point which is remaining from the unit number third, that is the general principles of planning of earthquake resistant structure. Okay. In last lecture, we have completed the most important point, that is the what is the DBE, what is the MCE. Okay, what is the MCE? Is design based earthquake. Second one is the maximum considered earthquake. In that we have considered three types of earthquake: one is major earthquake, moderate earthquake, and the very minor earthquake. So these three types of earthquake we have seen. After that, what is DBE? That point also we have covered. And the next point is the how to make whatever the principles we have to use to make a building as a earthquake resistant building. So we'll see this point, all the points related to the center of rigidity, center of mass, that we have completed, irregularities of the structure, irregularities of the structure. Okay, that point also we have covered. Philosophy of earthquake resistant design, that point also we have covered. Okay, what is maximum MCE, what is the DCE, okay, DPE, that difference also we have seen. Again, general principles of earthquake resistant design, that parameters also we have studied in the last lecture. So we'll take the revision of this last point and we'll go towards the next point. Okay, what are the general principles in EQ resistant structure? So there are the various points which are related to make the structure as a earthquake resistant structure. In that, first point is that there is a structure should not be brittle or collapse suddenly. Okay, this is the first point, which is very important. The structure should be behave like a ductile. Okay, if that structure is a brittle, okay, it can be, if dynamic load is coming on the structure, it will be behave suddenly, it will be collapse. Okay, so for that purpose, we should take care that all each and every element from the structure which will be act as a ductile in nature. It should not be behave like a brittle. Next one is the mostly we have to take care for the steel. Okay, because the reinforcement, whatever the steels we are using, that material should be a brittle material. That should be a ductile material. Sorry. After that, all the whatever the ductile behavior of that bent steel, distribution steel, whatever the stirrups, that should be tied with each other. Okay, so for that purpose, we have to take care for this binding of each and every component, concrete and the steel. Next one is the rather they should be tough, able to deflect or deform a considerable amount. Means whatever the materials we are going to use, that should be ductile. That is the first point. And second point, there is a deformation which should be in a considerable amount. Okay, that should be in a considerable amount. If deformation is more, then automatically there is also crack. Again, that crack would be goes on in increases. Again, corrosion will be happen because of the environmental impact. So other factors will be affected on the structure, and in such a case, the dynamic loads are coming on the structure. Automatically, some of the failure of structure will be occur. So for that purpose, we have to take care for this ductile nature of the building. And second one is the deformation should be in a considerable. In second one is the resisting elements such as bracing, shear walls must be provided evenly throughout the building in both directions, side to side as well as top to the bottom. Okay, means in this case, okay, whatever the we have to study, we have to learn the IS codes also. In that IS codes, there are factors or components which are given, which will be resist the dynamic loads, and that resisting element we have to add into the building. Okay, what are those resisting elements? First one is the bracing or the shear walls. Means shear walls or the bracing system, lessening bracing system. If you add, then they are in horizontal and vertical direction or in inclined position. If you add into the structure, what will be happen? They will resist the loads which are coming on the structure, and for that purpose we should make sure that resisting element should be added to the structure. Side to in the both the directions, side to side as in top or in the bottom. Okay, all elements such as walls and the roofs should be tied together so as to act as a integrated but unit during earthquake shaking, transferring forces across the connection and preventing the separation. In first point only we have learned about the from this unit number 1. The first point we have discussed, that is the load path. Load path is the condition from which all the whatever the load which is transferred from top to the soil. So each and every element should be tied with each other, and then they can transfer the load towards the top, towards the foundation. And so for that purpose, we should take care that each and every component that should be tied with each other. If any corner is there, that corner is loose, then what will happen? That is regular crack. If there is a big portion, then if such a dynamic loads are coming, automatically there will be a damage to the process. So for that purpose, we should take care about while planning, while constructing the building, each and every component should be tied together. So as to that building will be acts as a integrated during and unit during the earthquake shaking, transferring forces across the connection and the separation. Whatever the separation occurs, whatever the connections that will be going to be loose, that will not occur whenever the all the elements are tied with each other. And the next point is the building must be well connected, good foundation. Okay, building should be raised on the good foundation. If foundation is not good, if the soil is not good, we have to make sure that there should be some ground improvement techniques we have to use for increasing the capacity, so it can easily take the load of that building. So for that purpose, we have to make sure that should be connected with the good foundation and earth. Wet soil, soft soil should be avoided, and the foundation must be very tight together as well as the tight to the wall. Where the soft soils cannot be avoided, special screening that should be a good. It will resist dynamic loads. It should be act as a so each and every component will be connected from top to the bottom with each and every structure should be acts as a monolithic structure. Then it will be resist the different dynamic loads like the wind pressure or the earthquake loads. Okay, if you want to write, I will wait, or I should move forward. Prachi. Okay, next point is the general principles of earthquake resistant building. Care must be taken. Care must be taken that all materials used are good quality and are protected from rain, sun, insects, and other weakening actions, so that their strength lost. Okay, तर बघा, we should take care that each and every material should be in a good position. Concrete असेल त्यामध्ये cement, there is a sand, aggregates असतील, after that there is a steel, whatever the materials for roof we are using, that all should be in good position. If they are not in a good position, there will be a some of the because of this rainfall sun insects or other weakening action, their strength will be goes and reduces. If each and every component is very important for the structure, okay, from that if one or two components they are becoming weak, then automatically some of the strength of that building will be going to be reduces. And for that purpose, we should take care for each and every component. Each and every component should be prepared with a good quality material. Okay, that is the most important point is here about the material. The care must be taken that all materials used are good quality and are protected from air, sun, insect, and the other weakening action, so that their strength lost. Okay, so if we consider the cement, if we consider the wood, okay, and if they are not protected from the rain, if they are not protected from the sun, तर त्यावेळेला काय होणार आहे ऑटोमॅटिकली ऍट द बिफोर युजिंग ऑन द साइट they are weak in the strength. Okay, and if we are using such a material for the construction, automatically they will take some less load as compared to the other component. Is it okay? So for that purpose, we have to take care that all materials should be good, which having the good quality, and such a materials we have to use for the construction. Next one is the unreinforced earth or masonry have no reliable strength in tension and are brittle in compression. Generally, they must be suitably reinforced by steel or wood. Okay, तर बघा unreinforced earth or masonry have no reliable strength in tension. एका वेळेला काय होते की बघा टॉप स्टोरी मल्टी स्टोरी बिल्डिंग असतील आणि ग्राउंडला काय केलेलं असतं इट इज ओपन फॉर द पार्किंग. सो डायनॅमिक लोड जेव्हा त्या ठिकाणी येणार आहे तर त्यावेळेला त्या ठिकाणी जे लोअरचा जो तुमचा पूर्ण ग्राउंडचा जो फ्लोअर असणार आहे तर त्या ठिकाणी सुद्धा वी शुड मेक प्रोव्हिजन to resist the dynamic loads. If the opening area is over there, automatically there will be some effect for the structure. And so for that purpose, we have to make sure that some shear walls, shear walls astil, lessening astil, wetting astil, that provisions we have to make for that opening structure, that opening space. Okay, so that is the generally must suitably reinforced by steel or wood. Okay, so that makes as a structure which will be resist the dynamic loads by the providing the steel or the wood वुडच्या शिअर वॉल्स असतील किंवा स्टीलच्या प्लेट्स असतील त्या ठिकाणी आपण काय करायचं ओपनिंग एरियामध्ये वी हॅव टू प्रोव्हाइड. अँड सेकंड थिंग इफ द अर्थ जे काही मटेरियल आहे तर अर्थ मटेरियल बिलो द फाउंडेशन विच डोंट हॅव द स्ट्रेंथ और कॅपेबिलिटी टू बिअर द लोड तर त्या ठिकाणी सुद्धा आपल्याला काय करायचंय वी हॅव टू गो फॉर द strengthening of that soil so it can increase the strength. If you have completed, we can move forward. Okay, general principles of planning of EQ resistant structure. Okay, the same points, some of the points already we have covered. Okay, that points, general principles of planning of earthquake resistant structure. First one is lightness. Second one is the continuity of construction, projecting and suspended parts, building configuration. Now, what is this lightness? So, lightness is the earthquake force is a function of mass. The building shall be light as possible, consistent with structural safety and the functional requirement. ओके, तो बिल्डिंगचा डेड लोड असणार आहे तो एक्स्ट्रा जर लोड असेल तर त्या ठिकाणी काय करायचं आपल्याला फॉर दॅट पर्पज वी हॅव टू टेक केअर. अर्थक्वेक लोड जो आहे सिन्स द अर्थक्वेक फोर्स इज अ फंक्शनल ऑफ मास द बिल्डिंग शॅल बी as light as बिल्डिंग शुड बी ॲज लाईट मटेरियल आपण त्या ठिकाणी यूज केलं जातं पाहिजे बिकॉज ऑफ द वेट ऑफ द स्ट्रक्चर शुड बी रिड्युसेस. त्यामुळे आपण काय करतो whenever we are whenever you are constructing the building we are using the composite material for what purposes for reducing the weight of the structure. That is our basic motto. But okay, because of this light material what will be happen the dead load will be the structural load will be reduces and strength of the building will be increases. And so for that purpose we are using the composite material and so it will be reduces the weight of the structure means it becomes a light. Second one is the continuity of construction. Okay, in the continuity of construction, as far as possible, the parts of the building should be tied together in such a manner that building acts as a one unit. Okay. Okay, continuity in construction means from top to the bottom, whatever the elements that should be acts as a monolithic means it will be act as a one unit, each and every component which is tied with each other. Next one is the projecting and suspended parts. Projecting parts must be shall be avoided as far as possible, and the projecting parts If the projecting parts cannot be avoided, they shall be properly reinforced and firmly tied to the main structure, and their design shall be in accordance with the IS 1893. Okay, so IS 1893, that is IS code for the dynamic earthquake load. Okay, for the analysis of the earthquake loads, how to design, how to make sure that about the general principles. Again, philosophy earthquake कशी पाहिजे त्या ठिकाणी, these all the parameters which are given into this IS code, that is IS 1893. So for that purpose, if you want to go for this projecting and the suspended parts in our structure, we should make sure that that design shall be in accordance with the IS 1893. Okay, so this from most of the time we should reduce that, we have to reduce these projecting parts from the structure. We should avoid these projecting parts from the building. And if you want to add such a projecting part, suspended parts into the building, you should go for the design parameters which are given into the IS code. You should follow the steps which are given into the IS 1893. Okay, next point is the building configuration. The building should have a simple rectangular plan and be symmetrical with both with respect to the mass and the rigidity, so that the center of mass and center of rigidity of the building coincides with each other, in which case no separations sections other than expansion joints are necessary. Okay. So building configuration already we have studied. Building configuration in vertical direction, in a horizontal direction. There should be a irregularities in the structure. If irregularity found, automatically there will be a some of the damages or the lacuna in the building will be occur. And for that purpose, our structure should be be simple. It should be a symmetrical in nature. Okay, and symmetrical in nature. It should be distribute mass and the center of rigidity. We should consider this mass and the center of rigidity while planning the building, while constructing the building. Okay, and they should be coincides with each other, center of mass and the rigidity, so that the center of mass and the rigidity of the building coincides with each other, in which the case, in that case there is no separation, expansion, okay, will be happen. So for that purpose, we should take care for the regularities in the structure in vertical and the horizontal direction. That all points we have covered in the last lecture also. For the building configuration. तर बिल्डिंग कॉन्फिगरेशन जर व्यवस्थित असेल तर एक्सपान्शन जॉईंट्स किंवा असणार आहे, तर त्या ठिकाणी येणारा जो लोड असेल किंवा त्या ठिकाणी बिल्डिंगचं होणारं डिफॉर्मेशन, बिल्डिंगचं होणाऱ्या स्वे नॉन स्वे टाईपच्या फ्रेम्स, स्वेइंग होणार आहे ते बिल्डिंगचं किंवा डिफॉर्मेशन, tilting of the building, torsional effect, that all the effect will be going to be reduces. If you have completed, can we move forward? Completed? You just write the points. First you write lightness, second one is the continuity of construction, third one you write the projecting and the suspended parts, fourth one is building configuration. Completed. Okay, so you can see this point building having the plans with the shapes like L, T, E, and Y shall preferably be separated into the rectangular parts by providing the separation sections at the appropriate places. Okay, so you can understand from this L shape, T shape, Y shape, and the that there are the two Y shapes shown here. Okay, you can understand here these are the irregularity of the structures. Okay, such a types of the structures are available, shape of the buildings if like this, then these are the irregular structures. So these are not recommended structure, because if the dynamic loads is coming on the structure, such a types of the projection, that projection, after that these projections are going to be bent when dynamic loads are coming, if they are going to be bent, and for that purpose we should make sure that these components we have to reduce. काय करायचं आपल्याला या ठिकाणी जे सेपरेशन होणारे जे कंपोनेंट आहेत तशा टाइपचे आपल्याला प्लॅन हा बनवायचा नाहीये. आणि इफ यू वॉन्ट टू प्रिपेअर सच अ टाइप्स ऑफ द प्लॅन, वी शुड go for the recommendations which are given to the IS 1893. त्यामध्ये बघा हा L shape. L shape, in that L shape we have to, this is not recommended structure, but we can make it as a recommended by separation, by making the separation of these two. हाय सेपरेशन करायचं त्याला, आणि की हा दिस वर्टिकल जो सेक्शन आहे that will be become one and this horizontal section is become one. This now it is a not recommended, but we can make it as a recommended by making the two sections of this, two separation of this. Second one is the T section. You can see this T section also. Here is also we can make the building in vertical direction and in the horizontal direction. So we can make this by separation. You can see here this is not a structure that will become in equilibrium, or it will be distribute the load in equally in all the direction. Okay, so for that purpose we should go for the building should be a symmetrical simple building. Okay, overall form of the building कसा पाहिजे, simple पाहिजे. Second one is the symmetrical पाहिजे. Third one कसा पाहिजे त्या ठिकाणी, it should be equally, it should be whatever the center of mass of the building should be acts, तो काही inertia force आहे तो center of mass ला act झाला पाहिजे. So such a types of the shape we have to selected which are symmetrical, again which are centrally mass of center of mass will be act at the center. Okay, so we cannot use such a types of the building like X type, Y type, again T type, L type. हे टाइपचे जे बिल्डिंग आहेत ज्या ठिकाणी मोस्ट ऑफ द टाइम अर्थक्वेक अकर होतो विथ अ हायर इंटेन्सिटी, तर त्या ठिकाणी आपल्याला काय करायचे, सच टाइप्स ऑफ द स्ट्रक्चर्स वी हॅव टू अवॉइड. हा टाइपचा जो बिल्डिंगचा टाइप असेल, शेप असेल, तर अशा टाइपची बिल्डिंग काय करायची, तर आपण त्या ठिकाणाहून अवॉइड करायची आहे. इफ सच स्ट्रक्चर्स आर वर देअर, ऑटोमॅटिकली काय होणार आहे, त्या ठिकाणी डायनॅमिक लोड जर आला तर त्या ठिकाणी बेंड होऊ शकतो. एखादा जो प्रोजेक्शन आहे तर तो काय होऊ शकतो, त्या ठिकाणी फेल होऊ शकतो कॉम्पोनंट. सो फॉर दॅट पर्पज while constructing, while making the architectural planning, we should take care for the building should be made as a earthquake resistant building. If you have completed, we can move forward. Completed. Next point is the strength in various directions. Strength in the various directions. Next one is the foundation. Next one is ductility, and last one is the damage to non-structural parts. So strength in various directions. The structure shall be designed to have adequate strength against the earthquake effects along both horizontal axes. The design shall also be safe considering the reversible nature of the earthquake forces. Okay, strength कशी पाहिजे? It should be the strength, the structure should be designed with a adequate strength, and which will resist the dynamic loads which are coming on the structure in both the direction, in the both the axis, in vertical and the horizontal axis. Okay, तर आपल्याला each and every element कसा बनवायचा, it should resist the dynamic loads in the both the direction, in horizontal and the vertical direction. So we can achieve the building as a earthquake resistant building. Next one is the foundation. So what is this foundation? The structure shall not be founded on such a loose soils which will subside or liquefy during an earthquake, resulting in large differential settlement. Okay, so this point is very important. Baka foundation, because of foundation only. In unit number 1, we have learned this liquefaction concept. So what is the liquefaction concept? Liquefaction concept काय म्हणते आपल्याला, whenever the dynamic loads or whenever the earthquake is occur. Earthquake कधी होतो? Whenever the seismic waves are moving. Seismic waves ज्या produce होतात. तर because of these seismic waves, seismic waveलाच आपण एक earthquake असं म्हणतो, बरोबर का? तर यामध्ये at a smaller depth वरती जर water table available असेल ground मध्ये, earth crust मध्ये, if water table is available at a smaller depth, okay, from the top surface. So at that time, what will be happen? The soil is a loose soil. If the soil is a loose soil, if the soil having the bearing capacity or the shear strength is less, and if in that particular area, if the dynamic loads, because of the dynamic loads or earthquake is occur, because of this seismic waves, what will be happen? Seismic wave मुळे काय होणार आहे? Earthquake shaking, earthquake मुळे अर्थ क्रस्टचं काय होणार आहे? ग्राउंड शेकिंग होणार आहे. Because of this ground shaking, जो lower depth वरती जो water available आहे, that water will be mixed with soil, and because of this excessive shaking, that water will become on the top of the surface of the earth crust with in terms of mud. काय होतं पहिल्यांदा, जी सॉइल आहे आपली, समजा छोट्या डेप्थ वरती जर वॉटर अवेलेबल असेल, तर त्या ठिकाणी जर एक्सेसिव्ह व्हायब्रेशन, जे की अर्थक्वेक मुळे जे एक्सेसिव्ह व्हायब्रेशन होतं, तर त्या एक्सेसिव्ह व्हायब्रेशन मुळे जी काय सॉइलची जी काही शिअर स्ट्रेंथ आहे, that will be going to be reduces, and because of this excessive vibration, soil and water, they are mixed with each other. Again excessive vibration, because of excessive vibration, that mud that soil plus water, they will mix with each other and mud form, and that mud will be come on the surface of the earth crust. That is nothing but a soil liquefaction. आणि असं जर सॉइल लिक्विफॅक्शन ज्या ठिकाणी तुम्ही बिल्डिंग बांधले त्या ठिकाणी जर होत असेल, तर ऑटोमॅटिकली whenever dynamic load such earthquake loads are coming on the structure, automatically our building will be going to be collapse. So for that purpose, we should make sure that the structure shall not be founded on such a loose soil which will subsides or liquefied during an earthquake and resulting in a large differential settlement. हा फर्स्ट पॉइंट लिक्विफॅक्शनचा झाला. सेकंड पॉइंट इज दॅट देर इज अ सेकंड पॉइंट मध्ये काय बघा, रिझल्टिंग इन अ लार्ज डिफरन्शियल सेटलमेंट. इफ व्हेरिएशन इन द सॉइल जो आहे, तर वेअर वी आर गोइंग टू कास्ट द फाउंडेशन, where all the columns which having the soil properties are same, there is no problem. If soil properties मध्ये चेंजेस असतील, तर त्या ठिकाणी काय होऊ शकतं, तर त्या ठिकाणी सेटलमेंट, जी काही डिफरन्शियल सेटलमेंट म्हणजे काय, एका कॉलमच्या ठिकाणी सेटलमेंट कमी होते, दुसऱ्या कॉलमच्या ठिकाणी सेटलमेंट काय होते, जास्त होते. मीन्स दॅट इज द व्हेरिएशन इन द सेटलमेंट ऑफ द फाउंडेशन. And if there such a settlement also, differential settlement, if there is occur, automatically there is also dynamic loads are coming on the structure, त्या बिल्डिंग पण कोलॅप्स व्हायची शक्यता जास्त असते. Is it okay, Aishwarya? Differential settlement. Prachi? Next point is the ductility. The main structural elements and their connections shall be designed to have ductile failure. Okay. These will enable the structure to absorb energy during earthquakes and to avoid sudden collapse of the structure. डक्टिलिटी हा मेन पॉइंट काय सांगतो, तर डक्टाईल नेचर पाहिजे कशाचं, इच अँड एव्हरी इलेमेंटचं. जे काही स्टील एन्फोर्समेंट आपण यूज करतो, स्टील प्लस कॉन्क्रीट मधला पण बॉन्ड काय पाहिजे, त्या ठिकाणी स्ट्रॉंग असला पाहिजे. Okay, if there is a means if the ductile nature असेल स्ट्रक्चरचं, it will resist the dynamic loads. It will be resist करतच म्हणजेच काय, it will absorb the loads which are coming from the earthquake. Okay, so for that purpose, we have to make sure that the structure should be a ductile nature. So if the structure is ductile, automatically it will be resist the dynamic loads, and it will it will avoid the sudden failure of the structures. Last point is the damage to non-structural parts. So damage to non-structural part, in that already we have covered that suspended parts or the projections in the building. If such a projections or the suspended parts like a non-structural parts are still building, if dynamic loads are coming, they are making the structure as a weak. because of the collapsing, because of the minor damages of that non-structural element. Okay, the suitable details shall be worked out to connect the non-structural parts with the structural framing so that the deformation of the structural frame leads to minimum damage of the non-structural element. यामध्ये मिनिमम डॅमेज झालं पाहिजे कशाचा नॉन स्ट्रक्चरल इलेमेंट सुद्धा नॉन स्ट्रक्चरल इलेमेंट जे आहेत ते कशाला कनेक्ट असणार आहे दीज आर कनेक्टेड टू द स्ट्रक्चरल इलेमेंट जो काही तुमचा बीम असेल कॉलम असेल तर त्यालाच हे नॉन स्ट्रक्चरल कॉम्पोनंट आहे ते कनेक्ट केलेले असणार आहेत if the because of these dynamic loads these non-structural components are bent automatically they are making some of the damage for the structural element. Is it okay? And so for that purpose we should take care that damage of non-structural element should be a minimum damage. So automatically for our structural element whatever the damage occur which will be less. Okay, so these all are the provisions which are here for the making the building as a earthquake resistance building from light continuity of construction, projecting suspended parts, configuration, again strength in various directions, foundation, ductility, damage to non-structural parts. Okay, these all are the points from the unit number 3. Okay, can Aishwarya, can you give me the syllabus, please? Have you written in notebook? Okay. Our unit number 2nd. I will continue with the unit number 2nd in the next lecture. Okay. Try to come with the IS code IS 1893. Now unit number 3, 4, 5. Unit number 4, 5, 6. There are the some of the problems. So you should take printout of this IS code IS 1893. Okay. I read the syllabus. Effect of irregularities and architecture planning, that is we have covered. Center of mass, center of rigidity we have covered. Philosophy of earthquake resistant design, that is also completed. Maximum consider earthquake, design based earthquake, concept of stiffness, flexibility and ductility, that all parts we have completed from this unit number 3rd. Now we'll move towards the unit number 2nd. Okay, so I request to all of you, please come with the IS code, that is IS 1893. Only 2 units are remaining. That that is the unit number 2nd and unit number 4. Afterwards, we'll start the problems. So for conceptualization of the problem, you should understand the IS code steps. All the steps you should understand from the IS code, and then we will continue with the problems. IS कोडच्या सगळ्या जर स्टेप्स तुम्हाला समजल्या तर तुम्हाला प्रॉब्लेम समजेल. ओके, प्रॉब्लेम इज व्हेरी सिम्पल, डोंट वरी अबाउट दिस, बट यू शुड नो इच अँड एव्हरी स्टेप. ही स्टेप झाल्यानंतर पुढची कुठली स्टेप वापरायची हे जर तुम्हाला समजलं तर you can get easily the marks of the problem. Okay, that is the unit number 5. In the unit number 5, the design of reinforced concrete building for earthquake resistant load combination lateral load analysis as per the provision of IS 1893. Okay, that we have to learn in the unit number 5. That problem will study here, and you should understand this whatever the provisions given in the IS code also, and for that they have given this IS 13920. You download from the net, that from the Google you should download these 2 IS code, IS 1893 and second one is the IS 13920. Both IS code you download it, and second we will start now the unit number 2nd. I am telling you, after this chapter we'll start the problem. So before I am starting the chapter, you should have this IS code. Okay, because last unit number 6 is very simple. Only there are the seismic response, there are the control concept are there. So with a PPT only we'll complete this. Second one is the structural concept, unit number 4. From that, some dynamic configuration or some of the concept they are given here in the unit number 4. That is also very simple chapter is here. Now we'll continue with the unit number 2. That is the earthquake response spectrum. That is the earthquake response of system. Okay. Okay. So I on assignment already I have given to you for this unit number 3rd. Also write down the assignment. Fast you write, only 1 to 2 minutes are remaining. Write down the effect of irregularities and architectural planning on the structure. And effect of irregularities and architectural planning on the structure. Effect of irregularities and architectural planning on structure. Question number 2. What is center of mass and center of rigidity? What is center of mass and center of rigidity? Center of mass and center of rigidity. Write down 3rd question. Explain the philosophy of earthquake resistant design. Explain the philosophy of earthquake resistant design. Next one. What are the principles of earthquake resistant design? What are the general principles of earthquake resistant design? General principles of earthquake resistant design.